Hello all, I am Dr. Pravas. In today's class, we will discuss about the phases of the compiler, okay, with the help of one suitable example. Okay, see, the first phase, we have already discussed about the phases of the compiler, but in particular means today's classes, we'll discuss about means each phase of the compiler with the help of one example. So the first phase of the compiler, is lexical analysis. So what is the meaning of lexical analysis? It is a program, means lexical analysis. It is a program that reads the high level language, or we can say like source program. That reads the high level language program and breaks the program into meaningful words This is called as tokens. Okay. The second point, it also detects the lexical errors in the program. Okay, it also detects the lexical errors in the program. So what are the meanings of lexical errors? In the upcoming classes we will discuss, but now we'll try to understand what is the meaning of lexical analysis and what is the role of lexical analysis, means this page, lexical analysis page in the compiler. Okay, the lexical analysis page will convert the source program, or we can say like high level language program, or high level language, or high level language program. Okay, so the lexical analysis will convert the source program to tokens, source program or high level language to tokens. So one example, this is one of the program. What is this? Is one of the example of the program, or it is called as the source program. Position equals to initial plus rate into 60. So this one is called as source program. Okay. Now the lexical analysis phase of the compiler will convert this program into meaningful words or tokens. Tokens means what? Tokens means breaks the program into some meaningful words. Okay, see here, what are the tokens? So these are called as position is one token, initial is another token, rate is one more token, 60 is one more token. So there are four number of tokens. In the given program, means position equal to initial plus rate into 60. Okay, so means the lexical analysis page will convert the source program into tokens. So this one is called as source program and this one is called as tokens. Tokens means what? Tokens means some meaningful words is called as tokens. There are some important definition is also there is some important definition of token, but we'll discuss in the later. Details in about the tokens. Okay. So okay, so finally the first phase is over, lexical analysis phase. Next we'll see the next phase. The next phase is called as the syntax phase, syntax analysis phase. So what is the role of syntax analysis phase in the compiler? See, lexical analysis phase of the compiler converts the source program into tokens, but the syntax analysis phase will convert, means input tokens, means tokens are the inputs for syntax analysis phase, and it will convert to parse tree. Okay, see, the first point about the syntax analysis phase, it is a program that verifies programming statements programming statements syntactically correct or not. Programming statements syntactically correct or not, generally syntax analysis page will generally verifies. Okay. The next point, it detects syntax error. Next point, it constructs the parse tree. Syntax analysis page generally construct the parse tree. Okay. The syntax analysis page or second phase of the compiler takes tokens as input and it will generate parse tree and it will generate parse tree as the output. Okay. See, position, these are called as what? Tokens. These are called as the tokens. Tokens are the input for the syntax analysis page. Position, initial, rate, 60, these are called as the tokens. Okay. Now, how to construct parse tree? See here. This one is the parse tree. This one is called as the parse tree. This one is the parse tree of these tokens. Here, example is here what? Example is the generally position equals to initial. Position equals to initial plus rate into 60. Position equal to rate into 60. So this one is called parse tree. We have already discussed about the parse tree in theory of computation classes, how to construct the parse tree. So equal to left side position plus the left side is initial, star means our multiplication symbol, the left side is rate and the right side equal to 60. So these are called as the parse tree. Okay, this is called as the syntax analysis page. So syntax analysis page takes tokens as the input and it will construct parse tree as the output. Okay, so then next we'll see the next phase of the compiler. It's called as semantic analysis phase. Okay, see the next phase of the compiler, semantic analysis phase. So what is the meaning of semantic analysis phase? See, it is a program that verifies programming statements as meaningful or not. In some programming statements like meaningful or not, generally semantic analysis checks. Okay, means this page will check the programming statement is meaningful or not. Okay, the statement of the program. The next point, it reports semantic errors. Next point, it constructs annotated parse tree. It constructs generally what? Annotated parse tree. Okay, so how to construct the annotated parse tree here? Semantic analysis page. Semantic analysis page will take parse plus left side initial, star left side rate and right side is 60. So sorry. This one is the semantic analysis page actually. See, This one is the position, initial, rate 60. These are called as the means. So this one is the input means parse tree. This one is the parse tree. Parse tree. This one is called as the parse tree. Okay. So how to construct the annotated parse tree? How to construct the annotated parse tree? See, this one is called as annotated parse tree. Annotated parse tree. How to construct annotated? See, everything is same. Everything means equal left side position, plus left side is initial, star left side is rate, and here one thing is 60 is there. Here one thing 60 is there, but we don't know this 60 is means integer value or float value. I want to convert this means 60 value means 60 integer value to float, integer to float. So this one is the 60. This is called as the annotated parse tree. Annotated parse tree means it will just suppose we need we'll discuss about the means very detail about the annotated parse tree in semantic analysis space. But annotated parse tree is nothing but it will just add some means extra extra features. We can select extra features in the parse tree. This is called as the annotated parse tree, or it is also called as the decorated parse tree. Decorated parse tree. When we will convert from integer to float, this is called as the annotated parse tree. We can add some other decorations or other features in this means position also, initial also, rate also. But how to add, we'll discuss in the semantic analysis page. Just remember what is the meaning of annotated parse tree. Okay. Now we'll see the next one. The next phase of the compiler is called as the intermediate code generator. Now we'll see the next means fourth phase of the compiler. This is called as the intermediate code generator. So what is the meaning of intermediate code generator? It is a type of code. It can easily generated from high level language and also easily converted into assembly language code. It also means converted into very easily converted to assembly language code. So design of compiler becomes very simple. Okay, so what is the role? See, this is ICG means intermediate code generator. Intermediate code generator takes annotated parse tree as the input and it will produce as 3 address code as the output. So see, this one is called as annotated parse tree. This is called as annotated parse tree. Okay, this annotated parse tree now will generate the 3 address code. This is called as 3 address code. 3 address code means I'll just assign some new register. I will just assign some new registers. New registers means I'll assign this is just T1. I'll just integer to float means 60. I'll just assign integer to float 60 in T1 register. Okay, T1 I just store this value integer to float 60 into T1 register. Then let this one is T1. So then T2 is nothing but T2 equal to rate into T1. Here rate into T1. So rate into T1, this part will store in one more register. This is called T2. Okay, so T3 equal to initial plus T2. So I just store this value into T3. Then I'll assign T3 in position. Okay, so position equal to T3 means I'll just here assign 3 registers to store this annotated parse tree. I'll just assign 3 addresses. 3 addresses, or we can say like 3 registers to address the to store the annotated parse tree. So this is called the 3 address code. Okay, so next we'll see the next phase of the compiler. This is called code optimization. This phase is called as the fifth phase of the compiler, or this is called as the code optimization. What is the meaning of code optimization? This phase generally saves the time and space complexity, the time and space complexity of the target machine code. Okay, so generally it is a optimal phase. Generally it is optimal phase in the design of compiler. So code optimization takes 3 address code as the input, and it produces optimized intermediate code, and it produces optimized intermediate code as the output. See, what is the meaning? This one is called as 3 address code, 3 address code. This is called as the 3 address code. So code optimization will convert this 3 address code into optimized intermediate code. See, optimized intermediate code, I can directly optimize T1 and T2 at a time. So here T1 equal to what? Rate into this value into float to 60, or we can write here into float 60. We can also write. So T2 equal to what? Rate into 60. Here means we just reduce some registers. Here we are using 3 registers, but here we just reduce the 2 registers, means we will combine T1 and T2 using T1. Okay, then position equals to what? Position equal to initial plus T1. Position equals to what? Initial plus this part equal to what? T1. This part equal to T1. So in 3 address code, we are using 3 number of addresses, but after optimization, we just use what? How many registers? Only 1 registers. So we can save the annotated pass tree using 1 register, using only one registers. So this one is called the 3 address code, and this one is called the optimized intermediate code. Optimized intermediate code, or we can say like optimized 3 address code. Okay. Next, we'll see the next phase of the compiler. The next phase of the compiler, this is called as the code generation. Code generation means this phase generates the required assembly language, by selecting the proper instructions and registers. So it is a machine dependent phase. So code generator or code generation takes optimized intermediate code as the input and produces target program as the output. See, the code generator phase, this is my optimized intermediate code. This is my optimized intermediate code. Now I'll just assign how. See, I'll just move this 60. I'll just move this rate into 1 register. This is R0. The first register, this is called as the R0. Then I'll use multiply, move this rate into R0 register. Now, so R0 register will store what? Rate. Okay. Then multiply this 60 with R0. Multiply 60 with R0. That means this is called T1. This is the T1. So finally, this line is over. Now, then move initial into R1. So now R1 contains what? Initial. R1 contains initial. Then add initial with T1. So initial means now R1 with T1. T1 is nothing but what? R0. T1 is nothing but what? R0. So add R1 into R0. T1 is nothing but what? R0. Okay. So add R1 into. So finally, this one means initial means R1 and R0 both are added. And store in R0. Finally, R0 contains all these things, this part of the whole part. Okay. So finally, R0 will assign to position. So move R0 to position. So this is called as target program, or this is called as assembly code. Assembly, this is called as assembly language or machine dependent code, or we can say like machine dependent code. Okay. So, or we can say like this is also called as the target program. Target program. Okay. So finally, we will just pass the source program or the high level language to the compiler. Compiler means lexical analysis. Lexical analysis, then syntax analysis, then semantic analysis, then intermediate code generation, then code optimization, then code generation will convert the source program to target program or machine dependent code or assembly language. Okay. So these are the phases of the compiler. We'll read in very detail about means how to convert, what is the meaning of this, how to code generation, means how to generate the code. So what is the meaning of code generation, what is the meaning of code optimization, we'll read in very detail. What is the meaning of annotated parse tree, how to construct parse tree, how to construct annotated parse tree, we'll read in very detail in the upcoming classes. Okay. It is just of the example, means try to understand what is the meaning of some different phases of the compiler with the help of one small means program, source program, like. Okay. So the next concept is symbol table. What is the meaning of, means what is the role of symbol table in the phases of the compiler? It contains information. It contains information regarding identifiers and constants present in the program. So my source program was, means my example was like what position equals to some examples like initial plus rate into 60. Okay. So it generally what the information regarding about the identifiers, constants are like this, or some variables we can say. So here there are generally three types of variables or identifiers: position, initial, rate, like this. But what are the types? Suppose type of position, type of initial, type of rate, like let it is int, let it is float, means type of rate equal to float, means how much memory will required, how much memory will be required for position, initial, like that is 4, 8, like, and scope of the variables we can say like, and some other we can say we can take some variables or some other informations it can take. So that's why symbol table is a very supporting phase of, means all phases of the compiler. Okay. Next one is the front end. Front end means, what is the front end of the compiler? The phases of the compiler, which are completely depend on source language and independent on target message. Okay. The phases of the compiler which are completely depend on the source language and independent on the target message. Source language, or we can say like source program. So front end always depends on source program but independent on target program. The front end generally includes first 4 phases of the compiler. First 4 pages of the compiler generally. First 4 pages of the compiler means lexical analysis, syntax analysis, semantic analysis, intermediate code generator. First 4 pages of the compiler is called as front end. First 4 pages of the compiler is called as always front end of the compiler. What is the back end of the compiler? Say the phases of the compiler, the phages of the means backend phase of the compiler, which are completely depend on target machine and independent on source language. Remember, front end depends on source program and independent on target program. So backend is the reverse of front end, means backend depends on target program and independent on source program. Okay. The backend backend includes the last two phases. Backend depends on means includes the last two phases, means code optimization and code generation. So the last two phases of the compiler is called as backend, and the first four phases of the compiler. The first four pages of the compiler means lexical analysis, syntax analysis, semantic analysis, and intermediate code generation. All first four pages of the compiler. The first four phases of the compiler is called as the front end of the compiler. The last two phases means code optimization and code generation is called as back end of the compiler. Okay, next one is the next point. It is a very important point. It is also note point. It is very important point. See, it is note point, or we can say very important. Designing of different compilers for the same source language on different machines is possible just by attaching different backends for same frontend. Different backends and same frontend. That means there are many compilers: C compiler, Java compiler, Python compiler, R compiler. Like there are a lot of compilers means for programming language. But remember, always same frontend of all compilers are same. Frontend of all compilers are same, but backend is must be different, and but different backends. So frontend must be same for all compilers, but compiler the backend is always different. Okay, so by attaching different backends for the same frontend, this is very important point. Every compiler has same frontend but different backend. So these are about the phases of the compiler. From next class onwards, we'll start the first phase of the compiler. Means we'll read very detailed about all phases of the compiler. We'll start the lexical analysis phase of the compiler in the next class. Okay, thanks for watching.